All attendees are in listen-only mode.
Good afternoon, everybody. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services for companies that are looking to improve their test and quality assurance practices. I'm the author of over a dozen books on software testing, as well as being the past president of the ISTQB. Attendance at today's webinar earns PMI PDUs. Thank you very much, Vicki Sasser, for reviewing the material for PDU status and for making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. PDUs are available for live webinar attendance only. If you have any questions during the course of the webinar, submit them at any time. Please note that they are answered only at the end. Hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software community because at RBCS, we're a not just for profit company. We've been doing them for 8+ years now. This is entering our 2018 season. If you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We are happy to provide a quote for any help you might need. Contact us at info@rbcs-us.com. So, fallacies of risk-based testing. How even smart people make mistakes when they try to apply a best practice like risk-based testing. So you might say, you know, what is this picture and what does this have to do with risk-based testing? Well, this picture is the Deepwater Horizon, which you may remember from a few years ago, which caught fire and burned for quite some time and created quite an ecological disaster, as well as killing and injuring quite a few people on the rig. It was a very good movie, I thought, made about it not too long ago. Good in the sense of how it's as good as well as you could describe a complex technical and engineering failure in a short-ish period without getting too pedantic and also keeping it interesting from a people point of view. But in case you missed that movie or you forgot about what went on with that, one of the major contributors to the Deepwater Horizon disaster was the failure to properly mitigate risk through testing, specifically a blowout risk, and that was what ended up happening. So, you know, it is possible in many different kinds of engineering to make mistakes when you're thinking about testing that don't result in adequate risk mitigation. And while the mistakes that you might make may not result in an oil rig blowing up and a bunch of people getting killed, it certainly you know, can do some damage. So, quote from Mark Twain here: "It ain't what you know, what you don't know that gets you into trouble. It's what you know for sure that just ain't so." In other words, fallacies, things that you believe that are not actually true. And there are all sorts of fallacies about software testing, and there's a number of them that have to do with risk-based testing. So I want to make you aware of 8 of them here today in the next 40 minutes or so. And this will help you avoid some of this fallacious thinking that really abounds about risk-based testing, so that you get the full benefit of risk-based testing from both a effectiveness and efficiency perspective. So the inspiration for this webinar, like why did you come up with this idea for a webinar? Somebody said to me, I was talking about risk-based testing and how it's a best practice and you really should do it. And they said, well, you know, risk-based testing, it just means you don't test everything. To which I responded, yeah, that's true of just about every kind of testing. In fact, that's true, not just about every kind of testing, it's true of every kind of testing. Now, we could get into sort of a extended discussion about whether the number of tests for a realistic size system is infinite or just very, very large. It turns out that it really doesn't matter because the number of tests is so large as to be practically infinite. So I did some calculations on this once based on something I heard from the people that wrote the Solaris operating system, and they said that there were more internal states in the Solaris operating system than there were atoms in the universe. So I did some calculations on that, and basically, even if you automated all of the tests and could run each test very, very quickly, it would take you more than your own lifetime, well more than your own lifetime, to just visit every state. And that's just state coverage. That's not even thinking about what about all the transitions between the states. And of course, an operating system is more than just a state transition diagram. It has all sorts of other behaviors associated with it. So you sort of get the gist. You are facing a practically infinite number of tests, and you are going to select a very, very small, finite subset from that set. That you're going to do that. Now, the question is, how are you going to do that? Are you just going to take a random walk in the big cloud of infinite tests that you could run, and then when somebody finally says you're out of time, you go, well, bummer, but there's all these other tests I could run. But that's always what you're going to say, regardless of how long you spend wandering around in the infinite cloud. So you need to have some sort of way of selecting that subset, and risk-based testing is about using an understanding of what could go wrong, how likely those things are to go wrong, and if they were to go wrong, how bad it would be. In other words, the likelihood and the impact, and using that to select a set of tests such that the remaining risk at the end of this whole adventure of testing that you're going to perform is as low as it can possibly be, given the amount of effort that you were able to expend. Excuse me. Now, related to this idea that risk-based testing is just some form of corner cutting or shortcutting, there are other people out there who will say, well, risk-based testing doesn't cover all the requirements. Now, this is unfortunate, but it has roots in some amount of reality, in that there are some people out there that talk about something that they call risk-based testing, which is actually not really risk-based testing, in my opinion. It's something that I'll get to later that is more just reacting to things, and again, I'll explain that a little further. But in this particular approach, it is indeed true that some requirements might end up not getting tested. Now, when I say requirements here, I mean things like business requirements in a traditional life cycle, or user stories and acceptance criteria in a agile type of life cycle. Now, properly done, risk-based testing will indeed cover not only all the risks, but all of the requirements, at least the important risks, the ones that are worth covering. And the way that you do this is that you use traceability or coverage analysis, or whatever your test management tool refers to this as, to link risks to requirements, as well as linking risks to tests, and linking the requirements to tests, either directly or indirectly through the risks, so that you can actually run a report that shows, hey, yes, every single requirement has at least one test associated with it, so therefore it is covered. Now, the question of, well, is that adequate coverage? Of course, that gets into issues like what the appropriate depth of coverage should be based on risk, which I'll get to shortly. And also just adequacy of the test, which is something that should be addressed through a review process where testers and possibly other stakeholders are involved in reviewing test cases or test conditions. Now, if you're doing this is what's called a blended strategy. It's a blended testing strategy that incorporates both risk-based testing and requirements-based testing. Now, this brings us to it's all about technical risk fallacy. In other words, what we're going to do is just basically reactive testing. Now, reactive testing is where there's no upfront planning, analysis, design, implementation of the tests. It's just, let me see what we get, and I'll start checking it out. Exploratory testing is a form of this. Using checklists, defect taxonomies, other forms of experience-based and defect-based testing. Those are all typically part of a reactive testing strategy. Now, I have no problem with reactive testing strategies per se. I think experience-based and defect-based techniques and reactive testing strategies are an important part of any sort of testing project, testing effort. It's just that they, by themselves, are very good at finding a large number of bugs, especially bugs that you might otherwise miss using other strategies and techniques. But that's pretty much all they do. And from a confidence building perspective, from a risk mitigation perspective, from a regression risk mitigation perspective especially, and even from an information generation perspective, they just don't do that much for you other than go and look at this big pile of bugs that we found. Now, not denigrating that, obviously defect detection is a major objective of testing typically, and it's very valuable to find defects, but we shouldn't assume that that's all testing is about. And so, you want to not only say, I'm just going to run a bunch of tests that I think are really likely to find bugs based on my experience or based on this checklist or based on what a brilliant tester I am and I can get in and break anything. But you also have to think about these other objectives that need to be achieved and also impact, not just likelihood. Finding a lot of bugs is all well and good, but you also need to test in areas that perhaps are not very likely to have bugs, but if they did have bugs, would be really disastrous. Then we have this one, the sort of the Lone Ranger approach, this idea that the test team doesn't need any help from anybody else to do the quality risk analysis. They're going to take requirements, they're going to take user stories and acceptance criteria, they're going to take whatever sources of information are out there about what is to be built, and without working with any other project or product stakeholders, any business or technical stakeholders, they're going to simply analyze this information and come up with risks based on that analysis and then test those risks. Now, this is really basically just applying some sort of risk heuristics to your requirements. So it's actually not risk-based testing, it's requirements-based testing with a risk awareness to it. It is likely to miss a lot of risks, and it's also likely that the likelihood and or impact ratings of the risks, which are of course actually requirements, will be wrong. And the reason for this is that my experience for the last 20 or so years working with clients, helping them get started doing risk-based testing, is I find that any one stakeholder or participant in a team or a project will be aware of about 25% of the risks at best, possibly less, but usually no more than that. And so that means that even really smart, experienced testers have a lot of blind spots here, and they're going to be missing 75% of the risk, just like these other really smart stakeholders would. Now you might say, well, if everybody's missing the same number, well, what's the point in involving a lot of people? Well, the thing is that everybody may be missing the same number, but they're missing different ones because their perspectives are different. So what makes risk-based testing really powerful is that you get those business and technical stakeholders, project and product stakeholders involved in this process. And yes, everybody's got their own blind spots, but collectively you see a pretty clear picture of what the risks are and what level of effort should be expended to mitigate those risks and the order in which those risks should be mitigated. So there's value in having a structured process for risk-based testing. There's value in templates. I've got risk-based testing process and templates and examples and articles and stuff out on the website. You can go out and download those for free, and those are certainly valuable and useful to you if you're starting this process. But the most important thing, and I was been saying this since well before the Agile Manifesto came along, getting the right people together to do the quality risk analysis is more important than those processes, templates, and resulting documents. Again, not that the processes, templates, and supporting documents don't have value. They do, but they will only have real value if you have the right set of people participating in the quality risk analysis process. Now, another fallacy associated with risk-based testing is this one, that, okay, well, risk-based testing will help us pick the right test cases, but it doesn't really tell you anything other than that. Well, no. That certainly is an important benefit, making sure that, where the risk is higher, you test more, and where the risk is lower, you test less. And I'll talk a little bit more about that in a minute. But there are other important benefits that you don't want to miss out on. So if you have proper traceability of your tests and your test results back to the risks that they cover, you can talk about which risks have been mitigated and which ones have not. And that's going to allow you to report your test results in a way that's going to be a lot clearer to people, because remember, if we do a group process for identifying the risks, then that risks list, that risk catalog is already defined in a way that people are used to, that they understand it because they helped create it. So you talk about which risks are mitigated and which risks are not mitigated based on your test results. You're actually talking to people about something they understand, which, contrast that with people who go into test results meetings or daily stand-ups or something like that and go, well, we had 852 test cases that we were going to run, and we've run 759 of them, and 100 of them fail, and the rest of them pass. And people are like, well, what does that mean? So risk-based testing can help make your status more understandable to people, more immediate in terms of what could go wrong if we release now. Not only do you want to allocate test effort based on level of risk, but you also want to run the tests in risk priority. So the higher the risk, the earlier you want to test, because one of the things you want to avoid with risk-based testing is this: why are we finding out about this for the first time right now? Which is a typical reaction that people have when you find some showstopper bug 2 days before the end of an iteration or a release. You really want to avoid that. Risk-based testing can help you do that, provided that things are given to you in such an order that you can test them in risk order. But people aren't doing that, then you can explain, look, I want to be able to give you the maximum possible warning about serious problems, but that means that not only am I going to want to test in risk order, but I need you to give me the stuff in risk order. And of course, one of the things that happens, it's kind of regrettable, but it does happen, is that we run out of time before we are able to get through all of our tests. Now, in a purely requirements-based approach or other strategies for selecting and prioritizing your tests, this can mean that important tests end up either not getting run, or the important tests end up holding up the end of the iteration or release, or pushing something to a subsequent iteration, and that, of course, results in a certain amount of unhappiness among testing stakeholders. But if you run your tests in such a way that the tests that remain to be run are always less important than the tests that have already been run, then you really are providing a good benefit to yourself and the team to say, well, we can stop testing at any point. The most important tests will always have been run, in the sense of the ones that remain to be run are less important than the ones that we've already run. It's all a question of how much risk the team is willing to accept. And this gets back to the reporting your tests in terms of residual risk. When you can say, look, this is the residual risk, in the sense of these are the things we haven't tested yet, or these are the things that we've tested and we know there are problems with. Are you comfortable going live with it like that? And now it becomes a risk-aware release decision, and you're triaging your tests based on that. And again, because the risks all came out of a common collective discussion, then everybody's making an informed decision here. So that's another really important benefit. Notice that part of this, actually not just part of it, but a lot of this that I've been talking about, these benefits, are associated with having proper traceability between your risks and the tests that are covering them. So if you don't have that set up in your test management system, then that's definitely something that you need to get in there. Okay, yeah, test design. Oops. Yeah, test design. So sometimes people will say, well, you know, risk-based testing is all well and good and it establishes a level of risk, but then, you know, what does the higher the risk, the more I test really mean? I mean, what exactly is that? They sort of consider the advice to be too Zen-like, in a sense, too abstract. And it doesn't say, well, you know, here are techniques that you should apply. Now, at the very least, I would say, well, this is a fallacy because properly done risk-based testing will actually give you sort of categories or scales of an extent of testing to perform. So the highest risk items get extensive testing. Going down the scale from there, it's more of a broad type of test. Cursory tests for less risky, sort of an opportunistic approach to testing for even less risky ones, where you say, you know, I'll look for a way of incorporating this into testing something else. And then reporting bugs only would be where you would run any tests at all. At least you wouldn't create any tests, but you know, if you happen to see any bugs in that particular area associated with that risk, you would report them. Now, at that point, you know, that may be enough guidance. Your testers may be clever and creative enough to just say, well, we're going to take it from there. But I've got actually on the website, on the articles page and the blog page, there's a brief write-up. I don't know, it's about maybe 3 pages long, that talks about selection of test design techniques and the appropriate coverage criteria for those techniques based on these extent of testing points on the scale. So it is a fallacy, as I said, that test design is not informed by the risk analysis. It is if you do it properly. Now, of course, these are just heuristics. You know, the point at which this can all be turned into a completely deterministic algorithm is the point at which human testers will be entirely replaced by machines. So, you know, we don't want to urge on that day. But it does give a lot of guidance, and it gives help to managers too, because it gives them a way of sort of measuring, are we doing enough? Are we doing too little with respect to each risk? Now, so far, what I've been talking about, a lot of it is kind of related to a certain I guess you could say sloppy thinking, or missing some pieces, if you will, of what proper risk-based testing is. There are also fallacies associated with sort of the opposite end of that spectrum, which is the sort of going overboard. And that happens, and I've seen that happen when people try to get quantitative about their risk-based testing. So I do like to use likelihood and impact as the factors that influence or that calculate the level of risk, and that I will typically assign numbers to those where the impact of 1 is the highest impact of 5 is the lowest, and same for likelihood. So I multiply those together to get a scale from 1 to 25 for the overall level of risk. So that may look quantitative, but those are actually just ordinal scales. By ordinal, I mean that they put things in an order, but they don't have mathematical meaning that way. So if I say that something has a risk priority number of 1, in other words, has a likelihood of 1 and an impact of 1, so 1 times 1 is 1. I say something else has a risk priority number of 2, so say an impact of 2 and a likelihood of 1, or vice versa, so that's a risk priority number of 2. What I'm saying is that first thing is more risky than the second thing. The thing with a risk priority number of 1 is more risky than the thing with a risk priority number of 2. But I'm not saying that the thing with the risk priority number of 2 is half the level of risk of the one with the risk priority number of 1. See, that's not the way that works. Because it's not actually a quantitative thing. It's not like what insurance companies do when they calculate expected payouts on insurance policies, and they're able to use statistically valid pools of data to calculate that expected payout based on the likelihood of a claim and the average claim. I've seen people try to do this where they use the risk priority number and try to say, okay, well, I can come up with a formula to predict the number of test cases or the number of person hours and so forth. And while those certainly could be used as heuristics or guides, especially if you're going to say I'm going to assign a range there, you try to again reduce this to some sort of deterministic algorithm, and it's not going to work. At least I have not seen it work. I'm certainly open to somebody comes along and shows me an example of here's how I did this quantitatively in my organization and it works. I'd be happy to come in and study that. I suspect that what you would find in that particular case is that what was going on there is some sort of outlier or unique situation that made it work. Like, for example, I wouldn't be terribly surprised if IBM had access to enough statistical failure data for a lot of their software that they could actually do this kind of thing, just because they have just tremendous volumes of this kind of information. Oracle might also be able to do it. You know, other large systems and database vendors, they may have enough such data, but most of my clients, when I go in and work with them, they couldn't do it. So what we really want to do here is focus on, thinking of this as a qualitative technique that allows us to identify test conditions. Those are basically the risk items, and then assign the appropriate level of coverage and the order in which to run the test based on likelihood and impact scores, which are, associated with some objective and uniformly agreed scale. So we should be able to say, look, very high or 1 impact means this, 2 means this, 3 means this. There should be well-defined criteria so that no matter who you ask in the team, if they agree about, let's say, the impact scenario, they will agree on the impact rating. All right, well, closely related to the reactive risk-based testing that I talked about before is this idea of documentation. We don't need no stinking documentation. We're not going to document anything. And again, to me, this is not proper risk-based testing. In proper risk-based testing, you would be able to say, here is my list of risk items. Here's the likelihood rating. Here's the impact rating associated with each one. You'd also be able to trace those down to the tests that cover them. Ideally, this is all in some sort of test management system, and it's captured there. It's not just an exercise that people went through and said, oh, okay, well, good. I'm glad we talked about that. And then you just go off and do it. Excuse me. That does happen, without a doubt. Often in conjunction with this purely reactive approach to risk-based testing, but sometimes just out of just sheer laziness. But keep in mind that if you don't capture this information, then those benefits that I was talking about before of aligning the allocation of effort and the prioritization, the ability to drop less important tests later, the ability to report your results in terms of risk mitigated, not mitigated, all those benefits pretty much go away. The only thing that you get out of it is, well, we have a collective consensus about what's risky and how risky it is based on a conversation. But if you don't have any notes from that, you don't have any documentation whatsoever from that, do you really have a consensus? All right. So those are the 8 dangerous fallacies that I wanted to review with you guys today. In the spirit of of last year, where we were keeping it concise and trying to make things quicker so that these sessions are a little more accessible to people. We've winding them up faster. So in conclusion here, we've got eight dangerous fallacies. And these are specifically associated with risk-based testing. I could do a similar sort of exercise and identify fallacies for various other testing-related things, but risk-based testing, as a lot of you will know, is near and dear to my heart, so I wanted to do this one. As we went along, notice that I pointed out, this is the way that this fallacy negatively affects your ability to get benefits from this technique, or is, as illusory, or might lead you down a wrong path. So that's the point of debunking these fallacies, is to help you do risk-based testing better and to make sure that you get the benefits of it, as well as to make sure that other people don't miss out or repudiate the benefits based on some of these fallacies. Because I've seen organizations that say, well, we've decided that we're not going to do risk-based testing because of X, where X was one of the 8 fallacies that I just went through. And it's kind of like, well, and it's not actually true, and by believing that that fallacy is true, you're cutting yourself off from that benefit. So hopefully this discussion here is giving you some ideas on how to avoid that sorry fate. There's more information. There's articles, videos, et cetera, out on the website, YouTube channel. That's all stuff that's out there for free, so feel free to go take a look at that. We'll go into the Q&A session here, and as always, I will put up the advertisement while we're in that session, which you'll notice includes my LinkedIn and YouTube and Twitter, email coordinates there. So please go ahead and submit your questions via the Q&A feature. Before we get to the questions, as you're typing your questions in, please remember that if you feel the insights and ideas like the ones you just heard can help you with your testing challenges, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We are happy to provide a quote for any such help that you might need. And our contact information there, info@rbcs-us.com. So let's see, I got a question from Alex here. Alex says, how do we calculate residual risk with the risk-based testing approach? So there's a detailed article that I co-wrote with a colleague at Sony, because I did some work with Sony in Japan on helping them get risk-based testing up and running in their organization. So this is something you can find out on the articles page. You go out to the articles page and do a search on risk-based testing, and it talks about reporting, measuring residual risk during risk-based testing. The short answer is, the sort of the executive summary of that is that what we do is you have your test management system, and your risks are in your test management system, along with the requirements or the user stories and other test basis elements, the things that you base your tests on. And when you develop your tests, what you do is you capture traceability of your tests back to what they cover, which would include the risks. It may also include other things like acceptance criteria or user stories or requirements or what have you. And then when you run the test, you now have a test result associated with the risk through the test itself, right? So the test result relates back to the test that was run, and the test that was run relates back to a risk. So if all of the tests that relate back to a risk have been run and all of those tests pass, then we can say that that risk is fully mitigated. Fully mitigated in the sense that it's as mitigated as it's going to get. If we've got a risk where there are tests that have been run and they pass, but there are also tests that haven't been run yet, so we don't know the status, then that risk is not fully mitigated because there's still information left to get. If we have a risk where some of the tests associated with that risk have been run and failed, we now have a risk that's not fully mitigated, and we know that there are problems with it that need to be addressed. So each risk can be classified into one of those three categories. Either it's fully mitigated, not fully mitigated yet, not fully mitigated, and associated with a known problem. And we can report our results in terms of which risks fall into which of those categories. So that's the executive summary there, Alex. The more detailed description of an example of how we did it at Sony, you can find by going out, as I said, to the web page, go to the articles page, and search for that article that I co-wrote on risk-based test results reporting. Let's see, got a question from Doug here. What different approach do you use for risk-based testing in an agile project compared to a waterfall project? Well, I'm happy you asked that, Doug. There is on the RBCS YouTube channel a really detailed response to that, a recorded webinar similar to this one that you can go listen to. So like with my response to Alex here, I'm going to give you the executive summary, and then if you want more information, you can go out to the YouTube channel and find that recorded webinar and give it a listen. But basically, in a waterfall or other sequential lifecycle model, or a traditional iterative model like Rational Unified Process, also called RUP, Rapid Application Development, also called RAD, in those sort of traditional types of life cycles, the risk analysis happens up front during the requirements definition phase, which in RUP would be called inception. And we would do that risk analysis, and that risk analysis would be, one hopes, relatively stable over the course of the project. Though, of course, the reality, one of the things that often causes waterfall projects and even RUP projects to break is that the scope and the intended delivery of the product changes over the course of the project, and that is very disruptive to the work that was done in the beginning of the project, trying to lock down the requirements. And so if that's happening, that's of course going to break your risk analysis as well. So Agile is created in part in response to that sort of dysfunction, where the traditional lifecycle models are very brittle in the face of change. And so at the beginning of each iteration, you go through that process of selecting from the product backlog the user stories that you intend to create in that particular iteration, right? And you go through a story grooming process, and you go through typically an estimation process to try to put story points on the stories, so you can see, well, yes, can those actually fit into an iteration or not? Now, when you do risk-based testing in Agile, what you do is you put the quality risk analysis process right in the middle of that little sandwich that I just described. Effectively, the beginning of iteration planning, you're going to do your story grooming, and immediately after the story grooming, when you've selected the user stories that you think you're going to create and gone through and cleaned them up a little bit, selected from the product backlog, you then do a quality risk analysis for those user stories, looking both at functional and non-functional areas of risk. And based on that, you come up with a risk category or risk register, risk catalog, or something like that for the risks associated with that particular iteration. And then you go into your estimation process. And the fact that you've done the risk analysis helps you more accurately assign story points to your stories, because you know the risks that are associated with them, and you know the level of risk associated with those risks. So basically, the risk analysis becomes a part of the iteration planning, and that's how it fits in there. Excuse me. Again, if you would like a more detailed explanation of that, feel free to pop on out to the YouTube channel. You can see it down there below, the coordinates for our YouTube channel. Subscribe, and then give a listen to that recorded webinar, and it will give you a much more detailed explanation. I'll probably rerun that recorded webinar at some point in the future because it was quite popular. And I think it's your question, Doug, is one that resonates for a lot of people. Okay. So I got a couple questions that came in there. That's good. We'll go ahead and close this session down. We'll keep it done within an hour. Again, fitting with the concept of making these more lightweight as we go forward. Now, before we do close it, though, I wanted to mention something about the webinar series this year. We're kind of changing things up a little bit. Some of you all may have seen this on my LinkedIn and other social media. We are going to do 4 of these sort of traditional style webinars this year. And when I say traditional style, these used to be things that would run for 90 minutes, but we're going to try to keep them within an hour or less. So we're going to do 4 of those, and then we're going to do 4 of the one key idea sessions, which I think some of you will be familiar with from last year. We introduced that idea, the one key idea. Those are the really, really focused ones. It's like a 20-minute, very brief presentation followed by 10 minutes of Q&A. So it's 30 minutes tops. It's focused like on a single thing. We did one on test automation ROI, for example, last time. So we're going to do 4 of those. And then we're also going to do 4 sessions of what I call 2 points of view at 2, which is going to be where I pick some influential person in the software business or software testing industry, and somebody who have a somewhat different take on something, some topic that they're known for and that I have expertise in as well. And we're going to pick that topic and we're going to discuss it. And that's, again, going to be short, like 20-minute kind of deal. And then there'll be Q&A. So hopefully you'll be interested in that. I'm going to be announcing that session here really soon now, probably sometime in the next week or so, the first session, which will happen in February. That's the 2 points of view at 2. So we try things and see how they turn out. So in addition to the free webinars, which you can sign up for at our website, rbcs-us.com, keep in mind that if you want any one of these webinars done for your company only, just send us an email. We're happy to give you a price on that. Sign up for our newsletter at rbcs-us.com. That'll get you valuable discounts on consulting and training services and a regular newsletter, which includes a featured article on software testing and quality and news about what we're up to. You see the Twitter coordinates there, Facebook coordinate, LinkedIn coordinate. You can connect with me on LinkedIn. Just to attend these webinars, you want to connect with me on LinkedIn. That's cool. Do remember to check your email over the next couple days. You might be the lucky winner of a free e-learning course from RBCS. You were registered simply by attending this free event. You can also subscribe to our podcasts on the website. You can find the RSS feed out there. So feel free to do that. Subscribe to the YouTube channel, as I said. If there are people that you know that would benefit from these webinars, you can point them to the YouTube channel. We've got literally hundreds of recorded webinars and videos and stuff out there. So all good free resources that we offer, as I said before, as a service to the software testing community, because at RBCS we are a not just for profit company. Please do remember, though, we got to keep the lights on, so contact us for a quote anytime you need consulting, expert services, or training related to software testing and quality. This concludes the webinar. Thanks for joining us today.